Bismillahirrahmanirrahim. We have already studied that every control system consists of three elements: sensor, actuator, and controller. But in reality, a control system is not as simple as it seems. For instance, we have to need simulate a control system for an aeroplane. Then it is not possible to insert an aeroplane to the computer or laptop. To solve this problem, we have to need a mathematical or dynamic model. For a mathematical model, we have some steps. In this session, I will share with you some steps of a mathematical model. So there are 12 steps to make a mathematical or dynamic model. The first step is to identify an objective. Identify objective means maybe you want to measure temperature, you want to control temperature or mass flow rate or any chemical process. Any chemical process. The second step is make a schematic diagram. Schematic diagram. For a schematic diagram, it is just a sketch. For instance, we want to control a height of a tank. Then there may be a tank, and for a tank, obviously, we want to control a flow height of a tank. Then there is a pipeline, and maybe there is a valve. The third step is assume all the properties. Assume all the properties. So there may be an area of a tank or density of a fluid or any property we will assume. The fourth step is write all balance equations. Write all balance equations. Actually, these balance equations we have studied in our fundamental equations. For instance, balance equations may be mass. Mass, that is change of mass in the system and mass out of the system. This is the fundamental equation we have studied in our maybe a momentum equation. Actually, this right all balance equation depend upon the input of a system. What are the input of a system? Write other relations. Other relation may be thermodynamics or there may be a geometry, reactions. The sixth step is determine spatial dependence. Spatial dependence, this actually totally depend upon the complexity of a system. Actually, this determine what kind of differential equation we use in our system. Maybe there we used a partial differential equation or ordinary differential equation. The seventh step actually determine degree of freedom. Actually, this tells that how many variables are involved. For instance, we have only find the temperature. For instance, we have only one variable, temperature, then we have only one equation. Means the number of variable is proportional to the number of equation. If we have one variable, then definitely have a one equation. If we have a two variable, then there must be a two equation. Then at this step, actually classify input. There may be a fixed input. In fixed input such as the density or any value, area is a fixed. They will not change. Disturbances. We study in our first lecture of a control where we say that the disturbance may be when the temperature of a night becomes low, then the overall temperature of a system decreases. And third is manipulated temperature. Manipulated temperature means, for instance, here in this example, the valve, we open valve, then definitely flow rate increases. So this time mass flow rate or the valve mass flow rate we can change. So this can be a manipulated variable. Ninth step is classify output. Output simply may be a state, or state can be find out from equation when we solve equation, or control variable. Control variables is a set point. Control variable basically is a set point. 10th step is 10th step we can say solve or simplify general balance equation. This equation, write all balance equation, this can be solved and simplify. And in the 11th step, simulate model at a steady state. In this step, we have an equation, so we make equation as the derivative becomes 0. So and then we find find our equations according by making derivative 0 and then find derivatives. 12th step is the simulate model at simulate a dynamic model at a step input. Actually this step input means we change input step by step as our output as we get a stable output.